Faro, Ofosu. Yeah. And actually, my dream is actually I love physics very much, and I want to explore in physics. So I've been trying to learn a lot about physics, and I enjoy learning physics and other related science courses. I've been passionate about physics that I try to explore in physics, and I took so many courses in physics, and been so I've been doing some experiments regarding physics. Here is some experiments regarding physics and electricals and especially electronics. Like I'm more into electronics. I love electronics and I love technology because I believe that the time will come. Even the time has already come. Technology is like the peak of everything. Technology has made life easy. It has made in terms of finance, marketing, education, medicine. Technology is like the advancement. AI. So today I've done so many researches and experiments, but today I want to construct the 25-volt amplifier. Yes, I've been working on it for some time now. And so to actually start, constructing the breadboard, you have to draw a circuit diagram. And this is a circuit diagram I drew. And I bought certain electronics. I bought the components that I'll use to construct this circuit. So actually, this 25-volt DC amplifier involve the combination of a TIP transistor, that's TIP41 and TIP42. These are the transistors, and it also involve the combination of resistors and capacitors. Yes, so I've done the calculations and everything, and I drew this circuit diagram for it. I've constructed a 25-volt amplifier before. This is the old one, yes, but I want to construct a new one, so I bought the new breadboard and I bought the electronic component which I want to use to construct the new 25-volt DC amplifier. So what I did was I had the TIP41, those are the transistors, the TIP41, TIP42 and TIP43. The TIP41, the 42 and the small one which is the 43. And also we have capacitors 1, 2, 3. Actually this capacitor is I name it the audio capacitor, or like the mic capacitor. Yes. And this is the circuit diagram that I drew for this. This is the microphone and this is the speaker. I use a mic because the mic will serve as the input source, the input signal, and the speaker will serve as the output source or output signal, or the output, like the amplified signal. Because normally what an amplifier does is that it takes in a signal, it receives a signal. An amplifier will receive a signal and amplify it. That is, it will increase its magnitude, or it will amplify it into a bigger signal. Yes, so that's what an amplifier does. We have current amplification, voltage amplification, whereby when a current is supplied, the magnitude of the current will be increased, and whereby when the voltage is supplied, the magnitude of the voltage will increase, which is the voltage amplification. Yeah, but today I'm trying to focus not more onto this current and voltage amplification. So that. So yes, so I redrew the diagram again because I saw that there was some things that were missing in the diagram. So I redrew the diagram again. So you can see that this is the mic, of course, which is the input, of course, which will receive the input signal, and this is the speaker, which will receive the output signal. And you can see that there's a resistor here and there's a resistor here, and there's also another resistor here and another resistor here. This resistor here, I call it a dropper, or normally we call this resistor a dropper because it will drop the current or the magnitude of the current. And also I have the TIP42 and TIP41, of which I talked about. And I think, yes, also You know, in transistors, you have types of transistors. Of course, you have the NPN transistor and the PNP transistor. But normally, transistors they also have this thing polarities. You have the positive transistor and the negative transistor. And when you come to the diagram, please, when you come to the diagram, you could see that I've written A or B, and here I've written C or D. The A or B means that this transistor receives a negative voltage, and the C or D means that this transistor receives a positive voltage. So whenever you see a transistor, to know the polarity of the transistor, you have to make readings, or you have to look at the readings on the transistor. Some transistors, their reading starts from C, and some transistors, their reading starts from D. So with all that, I'll show you how everything goes. Also, you could see that from here, from this resistor, it goes on. From this resistor, I mean, like, you have a capacitor, you have the diode, the resistor, the diode, the resistor, and from this resistor there's a wire connecting to the output, which is the speaker. And this wire, you could see that I've made a sign here. This sign means that I've not bridged the gap between these two diodes. I just made it because it will be able to pass through, but I'll not bridge the gap. So that's why I made this sign, to show that, like, I've not bridged the gap between the diode. So okay, so I'm in the process of doing arranging the electrical components on the breadboard. And as you can see, show it down. And as you can see, this is the arrangement. Yeah, so I'm in the process of arranging it. So I'm now going to arrange the TP3. Yes. I'm just soldering it so that it will look nice on it. That's what I'm doing. So I'm in the process of arranging it. When arranging it, you have to check especially when arranging the capacitor on the breadboard, you have to check the polarity to make sure you are arranging it well. The polarity here being positive, you have to check whether, you see here is gray, you have to check whether that place aligns with the resistor component, because this is where the power source will come from. So that's it. Also, I want to show that this is the arrangement of what I did here. So this is the dropper that I was talking about. Yes, this is the dropper that I was talking about. You could see that the dropper is a 27 kilo ohm and 5 watt dropper. They are the same. And this is the transistor that I was talking about. This is the output transistor that I was talking about, the two output transistors. And you could see the reading on this. If you could see very well, it's C2580. So the C will tell you that this transistor receives a positive voltage, and this other transistor, the reading is B688, telling you that this transistor receives a negative voltage. Now you could see that I added a heat sink. I placed the heat sink on the transistor because transistor is a very valuable electrical component, and due to its nature, it produces a lot of heat. And sometimes when this heat is produced, if this heat is not regulated in any specific way, it could lead to how do we call it? I forgot the term. If this heat, it will lead to overheating of the transistor, which will cause, like, I don't know, like the transistor will not function the way it's supposed to function. So it will lead to overheating. That's why I connected to the heat sink. And you can see that on the heat sink, I placed a type of insulator on it. The reason why I placed this type of insulator before screwing it to the heat sink was because if you don't do that, this receiving a negative voltage, and this receiving a positive voltage. That's, let me see, the C is receiving a positive voltage and the B is receiving a negative voltage. If you don't put it on a insulator and these voltages come together, there could be a spark or a blast. So that's why I place on a insulator before screwing it to the heat sink. Okay, so before I place all these electronic components on the breadboard, I had to test it to see whether they were functional, that they were working well. So in testing the diode, this is my multimeter. I've already tested it, and I know that all the electrical components on it are working very well, but I want to test it again so that you get to know or see yourself. So this is the sound. This shows this. I put the on the meter. I've placed it on this thing diode to show that, and when you put this thing together, you hear a sound indicating that what there's continuous flow, or there's continuous flow and there's no break. That's why you hear the sound. So the same way you can test using a diode, you can test the diode. So I'm about to test the diode, and this is how I test it. Mostly I place the black one on this, and I place the red one here where the ash one is, and you could see that there's no reading on this thing. There's no reading on the multimeter. Now I'll turn the polarities and check whether there will be also a reading on the multimeter. So when I was connecting this output transistor, I had to connect it to these transistors too as well. So normally what I did was that the base of this transistor will connect to the emitter of this transistor, and the base of also this transistor will connect also to the emitter of this transistor. The base of this transistor is already connected to this circuit already, so there's no need to connect it, but the base of this transistor connects to the emitter of this transistor. So I did it. The emitter of the base of this transistor will connect to the emitter of this transistor. So I'm just soldering it back. Yeah. The iron is not hot enough. Yeah, I think that's enough. So I think that's all. So that's all for the amplifying circuit. So I'm left with a transformer and a power source to start up this amplifier, and I think that will be all for it. Yes, that will be all. And also you could see that I connected some wires. The reason why I connected these wires was to ensure complete circuit, to get a complete circuit. Now you could see that in the drawing I use these lines or these curves as a form of these wires. That's the main reasons why I use these curves. So you can see that these curves are simply what I use the wires to illustrate on my circuit, and I think that's probably all. Yes. So it's like with the as I was saying, I was testing the diode. So when I turn the polarity, you could see that there is a reading on the multimeter. There's a reading on the multimeter which tells you that this diode is working very, very, very well. So now also I also test the transistor, this one, the TIP42 and the TIP41. I tested to see which one was the base, but normally the collector is the middle pin, and the base is, normally when testing for the transistor using the multimeter, if you want to test the pin which is the base or the base pin on the transistor, you also, is the same way as the diode, it's the same way as testing for the diode. So you please let me show you. When testing for the pin which is the base, you normally put this one here and put another one here. Now what happens is that when you put the pins of the multimeter on the two pins of the transistor, and there's a reading, okay, you don't stop there. You change the polarity of the multimeter pin and test it with the same pins on the transistor. And when there's no reading, then it indicates to you that that's the base of the transistor, because it will allow current to flow only through one direction, and that will be the base of the transistor. So I think I'm done with the testing of the transistor. And also the capacitor, you can test it using the multimeter. On the multimeter we have the symbol for the capacitance, of which you can test. On the multimeter we have the symbol for the ohms, we have the voltage, that's DC voltage, AC voltage. Yeah, you can also test the frequency. And I got a speaker. Yes, yeah. I also got a transformer, the power source that I was talking about, the transformer, and I also got two capacitors that will store the power, and I got a diode that will convert the AC to DC for it to power the amplifier. So right now what I'm going to do is that, and I've made the wires. You see this wire is connected to the speaker here, and this other wire is connected to the speaker, and this is the output wire for the amplifier, and they are connected to the speaker, and this is the audio wire. This is the audio wire. So what I'm going to do is that I'm going to play a song on my laptop, and I will see whether it will work. So I'm just going to test it. So I'm going to put in the power. Coming. Put in the power. So let me switch on the power. Now I've switched on the power. So right now I'm going to put the headphone inside here, and I'm going to play the song. I'm going to play the song. So let me test it. And here, so I guess it's working. So the amplifier is working well, but you can see that the sound is not that clear. It's because of the voltage of the capacitor. It's not up to its maximum. That's why the sound is not that filtered well. Yes, but I think it's okay. It's good. Let me increase the volume. So I'm coming. Let me increase the volume. And you can see it's loud. So here's my amplifying circuit that I've been working on. I just love technology, and it's nice. Very, very nice. I'm happy. So there is it. That's all. Audio input, the audio wire that I was talking about. So right now I'm going to start. I'm now going to play the song. I'm going to play the song in the laptop, and let's see how it works here. So let me see. I've started. Now let me play it. You can see that the amplifying circuit has started playing. So that's it. It has started playing. You can see if I remove the wire, it stops. When I join the wire, it starts playing.